Next concept is analog to digital conversion. Last class we discussed about how we convert digital to digital conversion. Here we are going to discuss how analog to digital conversion. Here analog signals created by microphone or camera is converted to digital data. To convert analog signals to digital data, we use PCM, nothing but pulse code modulation. This digital data will be converted to digital signal. This is analog to digital conversion. Now we are going to explain the PCM. PCM is nothing but pulse code modulation. PCM is used to convert analog signals to digital data. Here, PCM is encoder at sender and decoder at receiver. The encoder has three processes. This diagram is PCM encoder. It contains three processes: sampling, quantization and encoding. Okay, here you can see that here analog signals is passed to PCM encoder and it is converted to digital data. In PCM encoder there are three processes. Sampling, after sampling you will get PAM signal, nothing but pulse amplitude modulation. After quantization we will get quantization signal. After encoding we will get digital data. Next is sampling. What is meant by sampling process? Here we convert the continuous time signal, nothing but analog signals, into discrete time signals, nothing but digital. Okay, pulse from the analog signals are simplified at the every t second. Means we are going to convert pulse from the analog signals are simplified at the every t second. Means we are going to simplify at every t signals. It is called simple interval or period. Okay, it is called as sample interval or period. Here inverse of the sampling interval or period called as sampling frequency or sampling rate. It is given by Fs is equal to 1 by Ts, nothing but 1 by sampling interval or 1 by period. Next is three sampling methods is there. First one is ideal sampling, natural sampling and flat top sampling. Out of these three we are going to use only flat top sampling. Natural ideal sampling, this is difficult to implement, so we are not going to use this one. Okay, next one is natural sampling. Here what is natural sampling means high speed switch is turned on for only small period of time when the sampling occurs. So we will not use this one also. We will use flat tap sampling. Why we are using only flat tap sampling? The most common sampling method. This is the most common sampling method. To create flat top sampling, this is refers to as a PAM. Here you can see that we will get the PAM signal. PAM signal is nothing but pulse amplitude modulation. What next? Under that sampling rate is there. What is meant by sampling rate? Sampling rate is nothing but at least 2 times the highest frequency, not the bandwidth. Here we are going to consider only the highest frequency, not the bandwidth. Only will consider frequency. So sampling rate is equal to 2 into frequency maximum. If the analog signals is low pass, we discussed what is meant by low pass and band pass in previous model. What is meant by low pass means the frequency will start from 0 itself, means FM means F minimum, frequency minimum will always start from 0. But in band pass the frequency minimum will start in between the frequencies, means it will not start from 0, it will start from somewhere in the frequency. The in analog signals is low pass, the bandwidth and highest frequency are the same values. Here in low pass analog signals, bandwidth and highest frequency are same values, both are same values. Here in this band pass, the bandwidth value will be less than value of frequency maximum. This is the difference between the low pass and band pass analog signals bandwidth and the frequency value. Okay, we completed the sampling process. Next process is quantization. What is meant by quantization? After simplified signal, it will be quantized. Result of what is the result of sampling? What is the result of previous process? Before quantization we use sampling. What is the result of sampling? Is nothing but set of pulse with amplitude values between the maximum and minimum amplitude of the signal. This is the result of sampling. Here you can see that there are 4 steps in the quantization. We are going to use 4 steps to get the quantization signal. First step is we assume the original analog signals as amplitude between the voltage minimum and voltage maximum. Next step is we divide the range into L zone. L zone nothing but level zone, each of the highest delta. How we are going to calculate the delta? Means delta is equal to voltage maximum minus voltage minimum divided by L. L is nothing but the number of levels. Next step is we again quantize the value of 0 to L minus 1 to the midpoint of each zone. Next step is we approximate the value of sample amplitude to quantized value. Means we are going to approximate this value to this. We will take the example. Here voltage minimum is minus 20, voltage maximum is plus 20, and L is equal to, L is nothing but number of levels is equal to 8. How we are going to calculate the delta? Delta is equal to voltage maximum is plus 20 minus voltage minimum is minus 20. We will get 40 divided by number of levels. Number of levels is 8. We will get delta value is equal to 5 volts. These are some topics of quantization. Under quantization, what is mean by quantization level. Let L is equal to number of level. How we can choose L? L depends on range of amplitude of the analog signals and how actually we need to recover the signal. If signal has two amplitude, then we need only two quantization level. I told that the choose of L is depend upon the range of amplitude. Here we use two amplitude, then we will get two quantization level. Here signals like voice has many amplitude, then we need more amplitude values. Here for audio, level is normally to be 256. Normally we use 256 level for audio. For video we are going to use 1000 levels normally. For choosing lower value of quantization level increases the quantization error. Quantization error, when it will come means when you are going to choose the lower value of L. Next, what is meant by quantization error? Quantization error is nothing but difference between the PAM value and quantization value. PAM means pulse amplitude modulation value and quantization value. Quantization is an approximate process. Input value to the quantizer are real number. Number is nothing but decimal values. Output value for the quantizer are the approximate value, means we are going to convert this real number, nothing but decimal values, to approximate value. Okay. Output values are chosen to be the middle value in the zone. And normally we choose the middle value in the zone. Input value is also at the middle of the zone, means there is no error. There will be no error if the input and output value in the middle of the zone. If there is a difference between output value and input value, then there will be a error. Next topic is uniform versus non-uniform quantization. What is meant by non-uniform quantization? Can be done using the process called compounding and expanding. A signal is compounded at the sender before conversion. The signal is expanded at the receiver after conversion. I told that compounding and expanding. What is meant by compounding? Compounding is nothing but it is decrease of the voltage amplitude for larger value. Expanding means increases the voltage amplitude for smaller value. For non-quantization, effectively to reduce the NRZ decimal of the quantization. Here SNR dB is nothing but noise signals to noise ratio decimal of the quantization. Next, last process in PCM encoding is coding. Quantization values are encoded as n-bit code, means we are going to convert these values into bit form, nothing but we are going to convert this 2 into zeros and ones of binary. Quantization value is 2 encoded as 0 1 0. You can see that the 2 is converted to binary values. 0 means, here 0 means we are not going to add 1. Here 1 means we are going to add 2. Yeah, 0 is there, means the addition of these three binary values is 2. For converting 5, we'll consider here 1, here 0, here 1. Means here 1 means we have to consider 4. 4 plus 1, 5. This is the conversion of quantizer. This is quantizer value. This is encoded bit. Relationship, next one is relationship between the quantization value and number of bit n is given by n is equal to log L base 2, or 2 to the power of n is equal to L. Bit rate is given by bit rate is equal to sampling rate into number of bit per sample is nothing but Fs. Sampling rate into n is nothing but number of bit per sample. We completed encoding part. Here onwards we are going to explain PCM decoder, original signals recovery. This can be done by PCM and decoder is used to recover the original signal. Here in this diagram you can see the components of PCM decoder. PCM nothing but pulse code modulation decoder. Here we use input as digital data. It will be sent to PCM decoder. PCM decoder contain make and connect samples and low pass filter. Here after passing digital data to PCM decoder, it will go to make and connect samples. This will convert this digital data into staircase forms of signals, and this staircase is passed to low pass filters. This low pass filters to smooth the staircase signals into analog signals. Why we are using this low pass filters means smooth the staircase signals into analog. Here PCM bandwidth is there. Minimum bandwidth is equal to C into N into 1 by R. Here we have to substitute the N value. What is the N value? Is nothing but NB into Fs. NB is number of bit per sample. Fs is sampling. Fs is sampling rate. And in next step, here we have to substitute Fs value. Fs value is nothing but 2 into bandwidth of analog signals, and the value of this is 1 and C value is 1 by 2. Then at last we will get minimum bandwidth is equal to number of bit per sample is greater than bandwidth of analog signal. Next is maximum data rate of channel. The Nescade data rate of the channel is N. Maximum is nothing but Nescade's maximum is equal to 2 into B into log L base 2. This formula can be gained by these 5 steps. Please go through these 5 steps in the PDF notes we will get this formula. Okay, nothing but n max is equal to 2 into b into log L base 2. This is in the give the unit as bps, bit per second, and maximum required bandwidth will be given by the previous arguments can give us the maximum bandwidth. Using this formula we will get the minimum bandwidth, means this n 2 into log L base 2 will be shifted to here. Then we will get the minimum bandwidth. Minimum bandwidth is equal to n divided by 2 into log L 2 hertz. The unit is hertz. Here we will use bit per second as a unit. Okay, this is the end of analog to digital conversion topic. Here only we concentrate on PCM. It contains 3 processes. First one is sampling, second one is quantized, third one is encoding. After encoding we are going to decode. Okay, these are the topics under analog to digital conversion. Thank you.